Every single day, without even thinking about it, you are living in a world built by software engineers. The alarm on your phone, the app you use to watch your favorite show, even the website where you order those cool sneakers, they were all built by software engineers. Think of them like digital architects. Just like how a civil engineer designs a bridge across a river to connect two pieces of land, a software engineer builds a digital bridge to connect problem to its solution. For example, when you are hungry and want food delivered, there is a digital bridge called Just Eat that connects you to restaurant. When you are lost and need directions, then you use Google Maps. It becomes your digital bridge that helps you navigate your way back on track. Or even when you want to video call your family across the world, of course you use Zoom, so you get the point now. But here's the thing, when you build thousands of these digital bridges, you start noticing patterns. The same challenges keep popping up over and over again. Well, years ago, 4 brilliant engineers known as the Gang of Four realized they were solving the same problems over and over again. And then they did something brilliant. They documented these recurring challenges and created proven, time-tested solutions for each one. These powerful solutions became known as the software design patterns. Today, I'm diving into one of the most elegant, powerful design patterns out there called the builder pattern. First, I'll describe the exact problem this pattern solves. Then, I'll break down the pattern's structure step by step and show you exactly how to implement it when you encounter this challenge. While I'll be demonstrating everything in Java, the beauty of the builder pattern is that you can implement it in any object-oriented programming language of your choice. Now, let's imagine that you are ordering a pizza online. A pizza, as we all know, can have many different optional toppings depending on your preference. Okay, let's think about how we can represent the pizza in a code. Basically, when you begin to write the code for the pizza object, you will immediately run into two big challenges. And you may want to ask, what are these two big challenges? Well, calm down, let me explain. The first problem is the telescoping constructor problem. You see, to handle every possible pizza order, the software engineer might try to create a constructor for each combination. This is known as constructor overloading. For example, he would write a code to consider anyone who wants a basic pizza, that is, a pizza with sauce and cheese, or a pizza with sauce, cheese, and pepperoni, or a pizza with sauce, cheese, pepperoni, and mushrooms. He would have also thought of a customer that wants a pizza that has sauce, cheese, pepperoni, mushrooms, and onions. But here is where it gets crazy. What if a customer wants a pizza with just sauce and mushrooms? Or what if a customer wants cheese and onions but no pepperoni? Suddenly, the engineer realizes that they need constructors for every possible combinations. Let's assume we have just 10 toppings. That is over 1,000 different constructors that the engineer has to create. As you can see, this is a nightmare to write and very hard to maintain. This ugly evergreen list of constructor is called the telescoping constructor problem. Well, another junior engineer might think a clever way to handle this problem is to take a different approach by just creating a set of subclasses to cover all combinations of the pizza toppings. But eventually, he's going to end up with a considerable number of subclasses. That too is a serious problem and it makes the code hard to maintain. This brings us to the second problem, which I like to call the confusing parameters problem. Now, some engineer might think they can solve this by creating one giant constructor that includes every possible pizza topping a customer could dream of. So, when a customer orders a pizza with tomato, mozzarella, pepperoni, and onions, the code ends up looking like this. It's nearly impossible to read and to understand. So, since the customer doesn't need other toppings, the engineer is forced to pass null as argument, and things keeps getting worse because this creates a confusion for any other engineer who didn't write this code. Now, the question is, what does that first null represent? What about the second null? And what on earth does true mean? It's incredibly easy to make a mistake and put an argument in the wrong position. Imagine accidentally putting pepperoni where the cross type should go. It is extremely easy to mix up the order of the arguments and create a bug. These are the core problems the builder pattern was created to fix. It lets you construct a complex object step by step using simple, readable methods, ensuring that the final object is exactly what you wanted without a mess. So, you now know the messy problems the builder pattern was born to solve. Now, the builder pattern comes in two main flavors, which are the static nested builder pattern and the classic builder pattern. I'm going to start with the one you will use 90% of the time, and this is the static nested builder pattern. This pattern is incredibly popular in modern code bases because it is clean, simple, and everything stays in one class. Now, let's take a closer look at each structure and how to implement this pattern. To make it work, we just need a few key parts. The first part is the product class. In our case, this class is named Pizza. This is the object we want to create. There are two key things to note here. The first is that the class constructor is private, which forces everyone to use the builder for creating the pizza object. The second is that the class properties are declared as final. This means once a pizza is made, it can't be changed. This is referred to as immutability. This ensures trade safety, which is also fantastic for preventing bugs. The next part is the static nested builder class. It is a static class that lives inside our product class. The static nested builder class has fields that mirror the product. Essentially, its job is to gather all of our customers' choices before the final pizza is made. The next is the fluent methods. These are the simple readable instructions we give our builder, like with topping or with extra cheese or add onions or add sauce and so on. Each method does something clever. It returns the builder itself. This is what allows us to chain our commands together into a clean, fluent conversation. The final part is the build method. Once we are done giving instructions, we call the build method. This method takes all the information it has gathered and uses it to call the private pizza constructor and passes itself in. This creates the final ready-to-eat pizza object and returns it to you. Now, take a look how clean and readable our code becomes when we use this builder to create a pizza. No more null values, no more confusing parameters, just a clear step-by-step set of instructions. This is why it is the most common implementation you will see in modern code bases. Okay, so if the static nested builder is so great, why does the other pattern even exist? Well, calm down, let me explain. You see, the classic builder pattern, also known as the gang of four builder pattern or the director-based builder pattern, is like a heavy-duty specialist. You pull this one out when the construction logic is very, very complex, or when you need different ways to build the same object. The classic builder pattern has a more formal structure with few more moving parts. Now, instead of starting with a class, we start with a blueprint called the builder interface. In our case, the builder interface is named Pizza Builder. Think of it as a recipe book. It lists all the steps you can take to build a pizza, but it doesn't actually do the building. Notice how each method returns the pizza builder itself. This enables method chaining, which makes our code read like a conversation. The next part is the concrete builder class. This class implements our pizza builder interface and does the real work. The important thing to note here is that builder follows the same steps defined in the builder interface. And finally, we have the director class. Think of the director as the shift manager who knows all the popular pizza combinations that customers usually order. However, you don't necessarily need a director. You might be wondering, if the director is optional, why do we need it? Well, calm down, let me explain. The director knows the previous recipes for building different pizza variations. You want a classic margherita? Boom! The director knows the exact ingredients to mix and the sequence to build that type of pizza. You need a supreme pizza with all the toppings. Boom! The director knows how to do that as well. Generally, the director class is a good place to put various complex construction things so that you can reuse them across your program. So, The classic pattern gives you ultimate flexibility by separating the how to build, which is the director, from the what to build, which is the builder, and the final product, which is the pizza. You might say that this involves more setup, but honestly, it is perfect for those really complex situations. Now, let's see how all the components work together using the pizza shop class. Here, you can see it shows two ways to build pizzas. The first way is to use the director. The second way is to skip the director and use the builder class directly to build the pizzas. So, let's recap. We've covered the two main flavors of builder pattern. The first is the static nested builder pattern. It is simple, clean, and keeps everything in one file. For 90% of your project, this is the one you will want to use. The second one is the classic builder pattern, which I refer to as your heavy duty specialist. It is perfect for complex scenarios where you need to separate the construction process from the final object, or when you have multiple ways to build the same thing. The most important takeaway is that both patterns solve the same core problems. They get rid of those ugly telescoping constructors and confusing parameters, leading to a code that is flexible, maintainable, and a joy to read. And that is it, my friends. I hope this deep dive into the builder pattern was helpful. Do subscribe and turn on the notifications so you don't miss the next video in our design pattern series. And I have one question for you. Which design pattern do you want me to cover next? Let me know in the comments below. Thanks for watching and happy coding. Bye.